with you, Mr. Fabiano Weimar. I would like just to say, Fabiano Weimar is a really old Plonista in here. He's probably older in the community than most of us in here. He was part of the team that was playing with Plone back in 2001, right? Or something like that. And he was always kind of a reference and a personal idol when it comes to server maintenance and development, and of course being funny. And I would like to say something else. If you say Fabiano Weimar, many people in the Brazilian community does not have a clue about who he is, because for us, he is Xiru. Okay, please, with me, Xiru. So, Xiru, floor is yours.
Hello, hello. Okay. So people ask me to do this in English. So if there is someone here that doesn't speak English very well and wants to ask me question in Portuguese, please go ahead. That's also okay. So, who was there on this picture? Yeah. So a lot of people here. That was the last Plone conference I went outside of Brazil. I should be somewhere. I don't know. There is a lot of people there. And after that, I think the last Plone conference I went was on this year. Not sure if you can see, but in the top there is cutted Brasilia 2013, which was basically 11 years ago. This was an event we usually had every year in Brazil, the free software, the International Free Software Forum in Porto Alegre. That's not happening anymore, but it was an event that every single year we were joining together and preparing for other events. So we were doing the advertisement from Python Brazil 9 and the Plone Conference 2013. There are some interesting people in this picture, including me here in the bottom and Gian, who actually names this room, right? There are other faces like Erico is also here, Gouveia, who was elected to the Plone board yesterday. Well, you know, I have been around for a while. But some of you may be asking, okay, what this guy have been doing here recently, right? If I was involved in Plone for such a long time, what I have been doing the last 10 years. Well, I need to say that I didn't have been doing a lot of Plone recently. This year, it wasn't an interesting year, the last year, just because I had the opportunity to get in touch again with some parts of the project. So I had the opportunity to go to the Teeny City Alpine Sprint this year, and because I had a good expertise in Kubernetes, since I was working with Kubernetes a lot during my last job. So okay, maybe it's a good opportunity to work on that, and that's why I'm here today. So it's just a way to, to contribute back a little bit from my personal expertise during, the last 7 years, let's say, where I was a little far away from Plone, but I was very much involved on Kubernetes. Not a core Kubernetes developer, but maybe almost there. So the idea today is, at least on my head, I'll try to explain how these two different worlds can come together, right? How Plone, which is, we all know that's a very trusted and safe content management system, can actually work in Kubernetes, which today is, famous for being the kind of de facto standard in the cloud-based infrastructures. But before we go much further, how many of you actually worked with Kubernetes before? Just raise your hand. Okay, so we have a lot of people that didn't work with Kubernetes before. I tried to explain the basics, so the presentation is still meaningful for people that don't know a lot about Kubernetes and want to know more. But I also try to give you some highlights from technologies that can be used together with Plone and Kubernetes to make the whole system and the whole ecosystem more interesting. Another question, how many of you know what Cloud Native Computing Foundation is? Okay, maybe fewer people then know what Kubernetes is. Kubernetes is a project. It's an open source project, and it's part of this foundation, the Cloud Native Foundation. And there is a lot of very interesting projects there. So I will pass in the next slides a few suggestions of interesting projects I have been working with that can be used combined with Kubernetes and Plone to create some really interesting and powerful solutions. Okay. I will also publish the slides later, so we don't need to worry about all the references. From now on, I will, show a lot of stuff. But I tried to create hyperlinks on every single reference, so we can go in deeper detail if you want. So, what's the main idea of using Kubernetes? What's the main benefit of using Kubernetes instead of just using something simple like Docker? Well, Kubernetes was designed to be more scalable, fault-tolerant, and in my opinion, the best thing we have in Kubernetes is this concept of self-healing. Once you have Kubernetes installed in your, cloud-based infrastructure in your cluster, and you say declaratively what you want to run and how you want to run this thing, Kubernetes is supposed to, at least for most of the scenarios, it's supposed to self-recover from most of the failures you have. So if you have a hardware failure, one server that's going offline, Kubernetes is going to detect that and reorganize the running pods. So basically, you have no impact in the application running. It doesn't seem like, important, but if you have a very critical application running in many, many servers, in physical servers, basically you are automating a good portion of the human work that would be responsible by guaranteeing the stability of the system. So this is the overall idea. And another important thing is, I think Kubernetes today have a very rich ecosystem. So you can run really critical production applications running different services based on Kubernetes. That's really amazing. So let's see a little bit how this whole thing works, right? This Cloud Native Foundation, they actually they compile a list of different software projects in different levels of maturity, and they publish this in 3 different levels. The graduated projects, the ones that are supposed to be used in production, they are more stable, they are more reliable. We have in the opposite corner, we have the sandboxes. These projects that are still, not very stable, they are still, growing up. And we also have, what's the other term? Well, I remember. But these ones are the most stable ones. They are not listed in any particular order. They are just, in alphabetical order. Argo is one that I have been using a lot. I will talk about this in the next slides. But here you have one that is interesting for us, with Helm. This solution for Plone on Kubernetes is based on Helm, which doesn't necessarily mean that you need to use Helm to use this thing. You can use Helm just as a template processor to create your YAML files for you, so we can start from there. There is a lot of people that actually run things in production using Helm. Personally, I don't, never did it. I prefer to do things in a slightly different way, but it's a very interesting tool. And there are a few other interesting tools here. For who watched the presentation from the Varnish guys, they talked about Prometheus, Grafana, other observability tools. These things are also very interesting to be used with Plone. So here we have, of course, Kubernetes. We have Prometheus, that's for metrics. Another interesting project is Thanos, that's to enable sustaining metrics in larger scale for Prometheus, and Open Telemetry. These are amazing projects. So let's talk a little bit about how these things can be used together to run Plone. So before we go in detail about the implementation, let's just clarify a few concepts in the Kubernetes world. So you understand how to map the way how we deploy the applications inside Kubernetes to different resources. So we have these abstractions that are used by Kubernetes, and I think it's important to clarify which ones are the ones we use. So we have pods. Pods are basically the most simple unit to run something in Kubernetes. It's where you have your container. But in Kubernetes, one pod is not just a container. The pod is actually a collection of different containers that are executed in the same network context. So you can have in Kubernetes one pod with 2 or 3 different containers running at the same time and talking with each other like they were in the local host. So they are, for example, most of time we have one pod with one container. That's the norm, let's say, for a lot of things. But sometimes it's convenient for you to run one pod with extra containers, combined with this, for example, to have a sidecar to collect metrics, or have an extra container in this application just to expose an API for monitoring, for example. So just remember that pods have this concept of it's the place where you run your workloads, but not necessarily it's just one container. Okay. Deployments. Well, deployments is a sustainable way to run pods over time. So you may have a different number of replicas. So basically you have a deployment that inside of it you have a replica set, and inside of it you may have a certain number of pods. Let's suppose you want to run Plone with 3 nodes of backend. How you do, you need to have a certain abstraction to say, oh, this is my backend, and you want to have 3 copies of that running all the time. And this is done with deployments or stateful sets. Stateful sets is very similar to deployments. The difference is usually stateful sets are used for stateful applications. So when you have persistent data, usually you run this in a stateful set. Can you have persistent data in a deployment? Yes, you can. The difference is for Kubernetes, the name of the object that will be generated in the API will not follow a predictable pattern. In stateful set, you have the name like backend 0, backend 1, backend 2, and always follows this naming rules. And in deployments, you have a different way of naming things, but they are very similar, right? But by convention, that's the main difference. Jobs, the previous presentation, we're using Nomad, right, to run jobs, to processing videos. Kubernetes have the same thing. Actually, the first time I evaluated Kubernetes to run stuff was for batching processing, and you were basically doing the same choice between using Kubernetes jobs and using different tools for batching processing. And cron jobs, guess what? It's a way to run jobs with a given schedule, right? So here, a good case is I want to do a ZODB pack once a week, for example. How I can represent that using a cron job. That will run a job for you and pack your ZODB. Well, these are the main ones. From now on, the others are just, to glue pieces together. Like config maps and secrets, they are basically ways to represent all the different configurations and secrets. What's the difference between a configuration and a secret? A config map and a secret? Well, basically a secret is storing potentially confidential data, right? You may be storing their passwords, certificates, this kind of thing. So the way how secrets are managed in Kubernetes is slightly different, just to couple better with these concerns. And you have things related to storage. So you have volumes, volume clans and volumes. They are not the same. You may ask if you have a more professional deployment of Kubernetes, you are probably going to use an external storage provider that will enable you to say, oh, how much storage you may ask. So you claim some storage space and use this storage space to create persistent volumes. This is the more advanced part. One thing that I think I would suggest to be mandatory for everyone running Kubernetes payloads is using PDBs. Do not mix that with the Python debugger. Just the name is the same. But PDB is in Kubernetes word means pod disruption budget. It's just a representation of how you expect the cluster to behave during a situation where the number of replicas, the running replicas you have, is not the number you want. So during the deployment of a new version or during a hardware failure, some replicas of your services may be failing. So here is the expectation you have in the policy. For example, do not queue more than 50% of my running replicas at the same time, because if you do that, maybe my website is going down. This is defined on PDBs. Autoscaler. Autoscaler is one of my favorite piece of software in Kubernetes, especially for people that's not running workloads in colo, in physical infrastructure you own, but they are running this in the cloud. You can use the autoscaler to say, oh, look, all my backend nodes are really, really heavy. I have no more computing power. Please go and create more machines for me. And you can automate that with the autoscaler. I did some really interesting autoscaling deployments in the past, not for Plone, but for something more complicated, using 15,000, 16,000 cores in Amazon. So it works really well. And the last two, I think it's important to talk here is ingress. Ingress is just a component that usually goes in the boundaries, in the frontier of your cluster, and it's responsible by routing the traffic, the external traffic to internal services. It's usually an Nginx service or a proxy like Traffic that you receive the request and decide which different Kubernetes service you'll be responsible by doing this. Who watched the training from Erico? He was using Traffic with this in Docker, but he was doing everything in a single machine with a Docker Composer, right? Remember here you are handling potentially thousands of different machines with services really distributed. So you may need to have a way to actually receive the requests and drive these in different services, right, in the cluster. And the last concept here is operator. Operator, the name is terrible in my opinion. There is nothing related on operator is nothing it's not related to programming operators, nothing like that. It's not, but it's more close to the idea of a human operator, right? That actually needs to go and from time by time do some manual work to do something. So the idea of operators is a custom resource implementation. It's like a custom Kubernetes object to handle something in a more automated way. So instead of just using this standard resources, you can use an operator to do things in a more efficient way, right? When I developed it in the last sprint, the Helm shard for Plone, we decided to not use operators. So we don't add unnecessary dependencies for people to use Plone, right? To depend on this extra code. We just decided to create things the simple way possible. But there are at least one or two operators I would suggest you to use, or at least take a look if you want to run things for real, right? So for now, any questions? Especially for people that never heard about Kubernetes, I know it can be tough, right? Okay, so this is the recipe. Basically, that's the way we converted Plone to Kubernetes. So in one side of the screen, you have the usual components, how we usually work. So we have Plone backend, front end, Postgres, right? We have a lot of people using the storage today, the ZLDB storage today, using Rail storage. So we have Postgres, Varnish, we all love Varnish, and Nginx, right? Nginx for reverse proxy for routing. You may use Trafic too, but we just decided to use Nginx because Nginx is the actual supported implementation from Kubernetes project for ingress controllers. And here is how we mapped it, right? So backends are stateful sets, front ends are deployments, Postgres, Varnish are also stateful sets, and you have two Nginx, one deployment for Nginx to serve as a proxy, and another one for ingress. So ingress is a different object from the actual Nginx for routing, because in practice, my expertise say that different companies, different organizations usually choose the ingress controller in different ways. The company I worked for, I will not get my son at school, sorry. The company I worked for was using a proprietary closed source implementation from Citrix, I think, to do ingress controllers, right? So I just decided to use the open source one, but it's easier if you have this separation and you need to just replace this by other component if that's the thing you usually use in your organization. And in the end, the one I told you before about cron jobs for packs. Okay, so this is the way how we did it. Okay. So as you noticed, Kubernetes is it's famous for having this steep learning curve. It's not exactly easy to learn, right? But for a presentation and actually to develop these things, we had to have an alternative to enable people to go get the laptops running a Kubernetes cluster, so you are able to actually go and experiment with all this technology. For our lucky, well, today things are easier. Some years ago, that was not an option, but today we can run Kubernetes in your laptop if that's something you want. And there are a few alternatives. If you are an Ubuntu fan like me, you can use micro Kubernetes, or you can use things like K3D. Um, this, it is a lightweight wrapper for K3S. Um, and K3S is this certified Kubernetes distribution from Rancher. And this thing is pretty easy to install. Basically, you go run one line in your Linux machine, and you run Kubernetes in your laptop. Of course, you don't have fault tolerance. You don't have a lot of different interesting and very powerful features that a full Kubernetes cluster would have. But you have the Kubernetes API, so you can basically do anything you want the same way you do in Amazon or Google Cloud. Okay? So we just decided to use this thing. And here is the whole thing. I created, I think I linked this in the slides, but I created a repository with scripts if you want to mimic that. But this is the whole thing, right? Basically, you go and need to have this K3D thing running. You just need to have this in your machine, have Docker installed, of course, and kubectl and Helm. In Ubuntu, it's pretty simple. You can run this from the standard package on Docker, the open source version of Docker. Install kubectl and Helm from Snap. Just make sure you add your user to the Docker group. Basically, here you probably need to log out and log in again. So you reload your groups. So you have permission to talk with the Docker socket, right? So you just download this thing. I need to do a statement of caution here. I'm not very happy of getting curl, pipe, bash, anything. But, this thing is reliable, right? And you are running this in your laptop, so don't worry too much. After that, you can create a cluster. So just pretty simple, K3D, cluster create, my cluster. And after that, your default kubectl authentication, you'll be automatically extended to talk with this Kubernetes API in your laptop. So from now on, all the commands you run with kubectl and Helm, you work automatically in this new cluster. The tip is, if you already have other clusters, like, I had to manage 10, 12 different clusters in my last job. So maybe if you do that, you need to be careful so you don't overwrite other configurations when you do this. But it's pretty safe. And this is the whole thing, right? So the last line here, that actually goes and installs Plone on Kubernetes in your local machine, running Voto, backend, everything. Okay? Pretty simple. That's it. So one more slide, and I can show you this and open for questions. This one was from the last sprint, the Alpine Sprint we had some months ago. Pretty similar. The difference is it was a development environment, right? So we had to clone a repository and actually run the Helm charts from your local disk. And here we have different variations, different suggestions of how to install Plone using these things. Using Postgres to have the database, assuming that you already have a running Postgres with your database, you just need to connect this, having Varnish, not having Varnish, having just Nginx. So you have a few variations, right? Including having just Plone Classic without Voto. For this, we have everything. The dry run here, of course, means that this is not going to run for real in the cluster. If you want to run this for real, just remove the option. But one interesting thing here is using this dry run to produce the YAMLs, and after that, you open the YAML in the editor file and change anything you want. So that's one possibility. Why I'm talking about this? Well, because of this section. So I reserved 2 slides with some handle tips and tricks that can be used using this tool, right? One thing, and this strategy, I think it's getting more and more common in large companies, in large SaaS enterprise companies with many people in the engineering organizations, is you don't allow people to run things directly in Kubernetes clusters, right? It's probably giving too much power for people to actually give direct access to the Kubernetes API for a developer. Some people do it, right? Depending on the organization you have and the level of governance you have, maybe that's fine. But if you have, I don't know, 200 people, I hardly doubt that people will allow you to do it, right? You probably need to be more careful about the things you run in your physical infrastructure. So one way to do this and still use the good practice we proposed for Plone is adopt something like Argo CD. So basically produce your YAML files and put this in Git. And what Argo CD do is it keeps monitoring the Git content of a certain repository. And when something changes, it goes and deploys everything that changed for you. The interesting thing on this is if you do that correctly, it enables you to use, for example, pull requests to actually pass this infrastructure change by a reviewing process, right? So you can actually commit all the services you want to run, create a pull request, have approvals from other people you work with, and when this is approved and merged to a certain branch, this branch is actually deployed in production automatically without having human intervention and without having the actual need to, give people access, real access to the clusters. I think I was kind of a privileged person to actually have root accounts on most of the companies I work, but that's not the rule. Usually the rules is something more like this. Another thing, and that's, well, basically a suggestion and maybe an idea we can work. I think Plone as a software probably can do much better than we are doing today to work with observability. Today, most of the modern cloud-based infrastructure usually relies on different tooling to help people to understand what's going on in the infrastructure. If you have many hundreds or thousands of pods running in your infrastructure and something stops to work, we don't really expect people to go manually and get the logs in all the different machines, right? It's not really productive. Today we have great tooling for this. I just listed a lot of tooling, a lot of tools here. Grafana, Prometheus, Thanos, Loki. Loki was also suggested by the Varnish guys in the presentation they made. All these tools help you to actually operate these things in a distributed way. Remember, we are not running Plone anymore using a Docker in a single machine. This thing can be running in hundreds of different machines, right? So you need to have a way to just get the logs, but the logs are being stored in 100 different places. How can you get the logs in 100 different places, right? So you need to index these logs and have a way to carry, to search for this. Another one, well, I think at this point, everyone agrees that rail storage is the thing. Maybe not everyone. I know some people here in Brasilia that are running lots and lots and lots of websites, Plone websites, using Xiru yet. But for large deployments, I think the most stable implementation today is based on Helm storage. So our implementation in Helm already supports that out of the box, right? You don't need to do anything extra to have it. It's just ready to use. And the last one is Varnish Operator. Not sure if anyone here have heard about it, but it's a very interesting piece of software if you want to run multiple copies of Varnish to have not just a cluster with a single cache instance, but you have many, and you need to, to scale this thing, to monitor this thing, to have, a more sustained way to do upgrades, for example. So all these things are here as suggestions, right? And the last one, this is my favorite, especially for K3D. If you are running Plone on Docker, basically you are downloading the official Docker image for Plone from Docker Hub. If you do that a couple of times, you're probably going to get height limit by Docker Hub, right? Because they are downloading too much stuff. So one way to do it is actually import the Docker images in your Kubernetes cluster. So every time you create a namespace and you want to create a new instance there, you don't need to go and download the images again and again and again. They will be kind of imported in the cluster context, and they can be reused. It's like having a local cache for images. So you download just once, and after that, you just reuse the same image. Okay? This is this is probably something you really want to do if you want to play with the Plone Helm charts. Okay, so demo time. Let's see. I don't have a lot of time, but let's see if I can show you something. So here I have, I put in the Docker Helm. Oh, the support would help.
And increase the font.
Oh, right. Okay. So let's see. Okay. Well, bigger than that, I don't think it's possible. But basically, here I just cloned the repository, and every different directory you have here is a combination, right? So here you have Plone Classic without database. It means, of course, you have a database, but you're going to connect this database using a remote connection string. Having Classic with Postgres, Classic with Volta, Volta plus Nginx and Varnish, and Volta with Zio, which is an odd combination, but it still works. So here I have kubectl running. So to get all the pods, get pods -a. It lists all the pods in all the namespace, right? Pretty simple. I don't have anything here. I have a namespace called dev sandbox. Namespace, it's what the name is, right? It's just a namespace. It's the way how we usually organize things in Kubernetes. It's interesting to have different things running in different namespace, so we don't need to worry about name collision and this kind of thing. And if you want to run it, you can do something like this. So That's it. It's installed. Now we can get the pods. So here we have this dev sandbox. We have a backend, a front end, a Xiru server. Look, they are not ready yet. They take some time until they download the image, they start the service, they will ping the health check, and the way how Kubernetes check if a service is running is using a health check that actually goes and ping the service and respects for an HTTP return code to make sure that the service is running. So the containers here are linked to this concept. So we need to wait a little bit until they are running. Oh, front end is already running. Let me put this. Yeah, it's working. It's working. This restart here is probably because one of the components behind it was not working yet. For example, you restart the front end, but the back end is not running yet. Or you start the front end, the back end is there, but the Xiru is not there. So they are still trying to connect to each other. And now everything is running. Okay? So that's it. Of course, I can open and access this thing, but we are basically running out of time.
We ran out of time. So first thing is thank you. Xiru is around, please.